Hi everyone. Do you know what I like even better than receiving your questions and your feedback? It's when you share with us what you're doing with Octave. And today, I'm delighted to welcome someone who never missed any Octave developer session so far to present two very handy features he has developed on top of Octave for his IoT projects. So Thibaut here. This is What's New in Octave, your live developer session about Octave, the edge-to-cloud data orchestration IoT platform by CR Wireless. And today I'm delighted to welcome for the first time, Jan Burt. Hi, Jan.
Hi, everyone.
Jan is an IoT solution architect at Linkwave Technologies in the UK. And if you are familiar with these sessions, I'm sure you already heard Jan's name in former sessions because he used to ask questions, and we thank him for that. So Jan will present in about 10 minutes, but first, please welcome back Matt Morton. Hi, Matt.
Hey, Thibaut.
Matt is a principal engineer, system architecture on Octave at CR Wireless. Matt actually works on Octave's backend as well as Octave's APIs. So I'm sure you'll have many questions today for either Matt or Jan. Send your questions at any time during this live using the question box or the chat. We'll try to answer them live during the session when we can, or we'll keep them for the Q&A session at the end. As usual, the session is recorded and will be posted on CR Wireless YouTube channel in the coming hours. If you are watching this session on YouTube, check out in the description below for the link to register for the live session so that you can interact with the presenters next time. As a quick note, there's two ways for joining the session: through your web navigator or through a dedicated app. Prefer the app if you want to interact with the presenters. Now, let's see what's on the agenda for today. So if you attended the last session, you may remember that Matt briefly introduced OpenAPI documentation for Octave. Today, Matt will continue this topic and show you how to generate client code. Very exciting. After that, Jan will present two features he has developed on top of Octave: the remote provisioning via Octave APIs, very handy for big industrial use cases. You'll see that in a minute. And the implementation of a secret vault, a very nice feature that uses recent Octave features like the groups. So without any further ado, let's start with our first topic for today, Octave Open APIs. Matt, the mic is yours.
Thanks, Thibaut. Hello, everyone. It's really great to be back. 2 sessions ago in September, I came on the stream and teased a little bit of a new feature that we were close to releasing, which was the OpenAPI documentation and definition file. And today, I'm really proud to say that it is available. You can now go to openapi.octave.dev and browse through rich documentation rendered very beautifully, great examples. All of our public endpoints are documented with request and response formats, error type definitions, and rich descriptions. So I would encourage everyone to go and after the stream, check that out. We're very proud of it. We also have published the raw OpenAPI JSON definition file, which is available through the API at the location on screen, and also a simplified definition file, which is going to help with code generation, which I'm going to do a demo of and discuss a little bit today. So I've already mentioned, go out there, browse the documentation. It's really helpful. One other thing that you can do with OpenAPI is import it into client tools, UI tools. I'm sure many of you have used something like Postman or Insomnia. You can take the definition file raw, import that into your tool, and it will populate that with all of our endpoints ready to use. So it's really great. But today we're going to talk about generating client code. And this is something that you're going to be interested in if you want to get started with Octave very quickly. Perhaps you don't want to write a boilerplate HTTP client code, which is can be quite cumbersome to write. And the nice thing about using our OpenAPI definition is you're going to get new endpoints generated as that definition file is updated and we release new features. So we like to use a tool called the OpenAPI generator. There's a few alternates that you can use, but this one, in our experience, gives the best user experience. So I would encourage you to check out the URL on screen. It is a command line tool. It's multi-platform, and it has a really huge range of programming languages that it can generate client code for. Okay. So let me switch tabs now and take you to the OpenAPI documentation page, which is available publicly. And I'm not going to go through this in detail today because I feel like that's something that is very self-explanatory how this works. But I'm just going to scroll down a little bit here. And there is a link on this page to the simplified OpenAPI definition, which we publish, which is here. Now, the simplified document is something that we've been working on, and it is most compatible with this OpenAPI code generator tool. So we've run it through a few times, we've ironed out some of the hard edges, and we've come up with this file. So I would recommend you using this if you're going to use it to generate your code. Part of the demo, I have a simple stream which contains some simple temperature data as events, and we're going to retrieve those events and print something out to screen. So I'm going to switch to my terminal, and I've created a very simple Golang project, sample project. Golang is a great programming language, and it's very similar sort of syntax to something like C. So those of you who don't know it natively, I hope it will be easy enough to follow along. The first thing we're going to do is we're going to grab that simplified JSON file, and we're going to download it into the project directory. Now that it's there, I can call the OpenAPI generator CLI tool, and using the file that I just downloaded, the simplified file, I will ask it to generate Golang client libraries. And I can pass to it, it's very configurable, so you can specify different methods of generation, what you would like to do with certain fields, but that's all available in the documentation. So we hit enter, and now it's generating our client library, and it's done. So let's switch to VS Code. So this is the project that I just had open, and it's open in VS Code. Because I just generated this client library, I have to just make sure that it refreshes. There we go, just switch tabs there. Okay, so what do we have here? The first to using this client library is to create a new client object, which we do in these first couple of lines. In the next couple of lines, we set an authentication mechanism. Now, as you can see here, we've only supplied a token, as opposed to traditionally, when you use the API, you might use a user and a token. Octave forever has provided these single-use tokens that you can generate with restricted permissions. So you can restrict those to only be able to access certain streams. And that is intended for use with your application integration. It is more secure. You can specify how long these tokens can last, and you can delete them. So that's what we're doing here. We're creating a new map with our authentication key. The next step is to call the event API and use the find event method, which has been generated. And we are passing to this the method the company name, Octave Demos, which is what I'm using to demonstrate here, the stream ID, and then you can also optionally pass things like filters, which I've done. I've asked it to only retrieve temperatures that are greater than or equal to 24, and then execute that. And I'm given back multiple variables, a possible error if one exists, and the response. I handle the errors, if there is one. And then finally, I retrieve the event, or all the events, I should say, iterate through them, and then print out to screen the date format with the temperature. So let's see how that works. I'm going to call go run in my directory. And this is the generated output, as expected. It's retrieved, it's filtered the events, it's retrieved them, and it's printed them out to screen. So because the client, the OpenAPI generator is very mature, it knows exactly how to generate all these data types, all these endpoints, and all these object types in a way that would be idiomatic to your language. So in this case, we have Go structs, which is the sort of the bread and butter of the Go programming languages, to represent event and all of our API endpoints. If you were doing this for Java, it would generate classes and enums. And because it's generated structs, we have the ability to use code complete. So for example, I could call clients dot, and when I do so, I'm given all the different API possibilities here: stream, share, file, blueprint, cloud action. So they're all there, all generated. Let's choose device, for example. And here are all of our device API endpoints: add tags, count, find, install new firmware, provision, which is something that Ian is going to show shortly. And along with this, we have rich documentation. So let's take one that is a little bit more complicated, the aggregate event API. And all of that documentation that you would see if you went to the OpenAPI hosted website is all available in your code editor here. So you can see exactly what things are expected and be guided through that process. And then similarly, for the response objects, in this case events, this event is a struct and has all the fields that you would expect it to have. So here we have the creation date, the LMs, generated date, tags, etc. So it's all very easy to use. And I just wanted to finish off by showing a possible list of languages that are supported by this OpenAPI generator project. And as you can see, almost anything that you might want is available as a generator, including my personal favorite, the closure generator, because that's the language I enjoy the most using. So just to round it out, I'd really recommend trying it out, especially if you don't want to write boring boilerplate code. It's an evolving document. If you find any issues or anything, any sort of hard edges that you wish could be improved with the document, reach out and we can work on that as a team. And I guess now is the time to ask if anyone has any questions.
So I don't see any questions so far. Any question, guys, for Matt? Otherwise, we'll switch to Ian, and if you have any question coming, we'll keep them for the Q&A session maybe. So thank you very much, Matt.
Thank you.
And now that's the time to all right.
Are you seeing my screen?
Yes. Go ahead, Jan.
I do have a question. It had to be me.
Go for it.
Documentation on the filters is something that I think is one of the harder parts on these things. That would be something very nice to have. Is there anything out there?
So the filter language is documented on the OpenAPI page. I would recommend everyone take a look at it. There's a specific section on the left-hand menu. You can browse down to filters, and every single operator and operand is documented. But as always, if anything is unclear, please reach out, and we'll do more.
Okay, so let me start. As Tibor said, I'm Ian Bird. I work for Linkwake Technologies. I do solutions and work on the architecture of solutions in IoT and other things. It would have been very nice to have had all these OpenAPI and code generators before I started this first project, because this was written by hand from top to bottom, but it would have been very nice having this new feature, and I think people should take absolute advantage of this improvement on deployment. I'm going to start by talking about why we decided to do this. We had some requirements, which was we needed to deploy many units, and we're talking about hundreds of units, in a way that we didn't need to require somebody having to come into the Octave portal and do all the setup. So we wanted somebody from stores, or a technician, or somebody that is not a person that has a user inside Octave, to be able to do the entire provisioning process, since it is a production type process. We wanted minimum handling and supervision, which means if you do it manually in the Octave platform, you have to go in, set it up through the new device page, then you have to check the firmware, update the firmware, do the blueprint. There's a lot of manual supervision throughout the app that needs to be done to push a unit from where you receive it to where you can send it off to a customer. And we wanted to have minimum handling or supervision on this. So we wanted a full task cycle that could do everything from start to end, non-stop. And we wanted to do it for many units. We didn't want to do one unit, then another, then another. We wanted to batch 20, 30, 40 units if necessary, and have those units work their way through the system and the process. And we also wanted to know, since, and I guess you all know, it doesn't always work out as you expect. You might have a problem with the SYN getting activated. You might have a problem with the unit registering with the network. You might have a problem with the update of the firmware. There's many things that happen throughout the provisioning. We wanted to be able to go back and see the audit without having to go into Octave and see the operations, so that the person that's doing the provisioning can see what the history of that provisioning was. So we built a process. This process is built on the process guideline that Sierra has published, which, if I'm not wrong, is, give me a second, where are we? Here we go. Not here. Let me go into this one. Okay, let me go here. So This is a page where the solution developer journey has a deploy your service in scale and how you should deploy your devices and preparing. This is a full walkthrough of the process. The only thing I've done, the only thing I've done here on the presentation is, here we go. The only thing I've done here is put it into schematic. So basically, you scan in a device, it looks and sees if there's if the unit exists, if it's valid, if it's not valid. We pre-look this up. Then it starts a provisioning service that goes through a number of processes. And I'll show this better in a demo. So basically, so that we can go through a demo, let me go back to this other desktop. Let me go to this other desktop. Okay, here we go. This other desktop. This is a solution here. I'm going to do, hopefully in the next 4 or 5 minutes, I'll be able to deploy the complete unit and do exactly all that, which is provision it, update the firmware, update the blueprint, create tags, add a config to it, and I can do that directly from here. I first need to, the app is starting to run, which will run here in a second. This is all built on C#, but you can do that as Matt just demonstrated with Go, and on a much simpler basis than what I did this in the beginning. So let me just get this, which is a serial number. I switch over to here. I add the serial number. This on the store's front, what the store person would be doing, he would just be scanning in these numbers with the code barre scanner and adding them onto here. So that will launch a new device. That new device is now powered on. So it's going to start with registering. So if I come back here and look at Octave, I have a new device that's just been registered 10 seconds ago. If I come into my database to see the audits, I can see that we do have a new unit in here. And if I come back and execute the process, I can see that it has been registered. So we know that the unit has been registered, but it's still not up and running because, well, 29 minutes to go. And this is the part where we hope that it comes through fast. It's been powered on for a while, so let's hope it comes through fast. If we look at the code, basically what's happened is when we've scanned that in, I have an add a new unit in here, which is a process that basically creates an Octave connection. And what we do is, here we go. If I go here, it says provision a device. Basically the same thing that Matt has shown us a minute ago. I have a URL part here. I have a client, that's what I'm working with, which is basically this Cloud API client, which is just a representation of an HTTP client, which is an HTTP client I created. I pass in the base URI, which we're using. I pass in my token and my user. Whoops, I should be showing my password, should I? I'll get that changed in a minute. Okay, so basically what happens then is this main unit starts going in and provisions it, and that sets it up here. Now, what the app is doing while this is going on, it basically is checking to see if the unit has provisioned yet. So I go in, no, here on this one. So I go and read if the device is connected. I'm looking to see if that device has been connected or has last been seen in whatever time. So I'm looking basically to find out if this unit is connected or if this unit has read back anything. If it does, at that point, I put it into network ready, which means by now it has been seen. It will then go on to set the firmware. So in here on main, once it has been seen, let me just close this. It will go into a time handler, and once the provision is finished, what it will do, it will go and send, if it's provisioned and it's network ready, it will go and start footer. Where is start footer? Start footer here. So now it's going to be getting, if it's network ready, start footer. So if we come in here, it's already footer ready. Let me see. That went faster than I wanted. So it should be in a minute or two, it should come in with the blueprint. It doesn't have a blueprint or tag, so it's moving down that process, doing the same thing, launching a command over to Octave, waiting for the command to come back. When the command comes back, doing the next one, coming back, doing the next one, doing the next one. As we can see, we just had an update. What I suppose is going to, there it goes. We have a blueprint came back in, and now it's doing the tags. I need to refresh here. There's no tags. It should have tags by now. Come on, refresh. It has tags by now. So now it's saying blueprint is ready and success. So if I come into the audit, execute, we can see that it's gone through registration, photo in progress, photo finished, blueprint in progress, blueprint finished, tags in progress, and finished. And if we come here, it's completely finished. The user has not had to do anything. He just scanned the 3 codes in, and the entire process has been done, beginning to end, all throughout the code. Let me just remove this, cancel. No, okay, so basically what is happening is we have a number of processes in here that are checking the timer. They're running these events when the timer triggers, and these events basically go and check out to Octave what's going on. So there's these read commands which basically do the same thing. They have a string where they go out and read the device. They have a string where they go and see if the device ID and get whatever information they from the device. Like for example, read SIM we have here, and we read the SIM with a filter that I was asking you about because I had some trouble with this filter. So I'm looking in the inbox for messages that come back with activation complete. And I'm basically, when I get these, I compare it to the unit that I have, and if the element is an action, I return true, and I can go on to the next step. So coming back to my presentation, any question on that?
I don't see any question. I think it's a great demonstration how everything you see on Octave UI is actually reachable through Octave APIs. Everything. So if you want to do like what Ian did, automate do an automatic process for people like with bar scanners for the industry to do these massive registrations and so on, that's feasible thanks to these features. I think that's a perfect demonstration of that and how industry oriented it is as well. So that's great. Thank you, Jan, for that. It's really a great demo.
And I have to say after the OpenAPI, it will be a lot easier. And if you use the code generator that Matt demonstrated, it can be very, very simple to get to where you need to get on that. And the process and how you should set this up, this is a good link. Maybe you can share it, Tibor. This was something that it's basically Doc's solution developer journey, was sent to me by Agustin some weeks ago. Okay, let me go into the second part of the
I have a quick question for you, Ian, if you don't mind.
Absolutely.
How are you? How are you using the API to keep track of the state of the device, so you know when things are provisioned? Is it by using the device endpoint, or are you utilizing the operations endpoint instead?
I'm using both. It depends on what I'm trying to read. If I'm basically using the device most than any, and that's why I have a timer that goes off every 5 minutes, 4 minutes, 3 minutes, depending on what the process is. And it's basically querying. If I go back to the code here, let me go to the other. I'm trying to keep 2 desktops to not mess myself up. So basically, when I go off, I normally go off to the device URI. So I'm using the device interface here to query the device most of the time. Like for read if the BP, the business, the blueprint is ready. I'm using the same. I'm passing in variables of my own that I'm storing in resources, so I don't have to have them in writing. But I'm basically doing that. I'm going to the device interface to get the device interface most of the time, except for example, in this one where I'm actually querying the inbox. I'm querying for that device its inbox stream.
Yep, that illustrates like the multiple ways that we give people to keep track of things. In this case, you can look directly on the device and keep refreshing. For long-running operations like provisioning, photo, as I described 2 sessions ago, we have an operation endpoint, which gives you a sort of a more generic long-running operations query. So you can see how things are going. If you're doing a batch of hundreds of devices, that's also very helpful. And then Ian just demonstrated that there is an inbox stream, which is a stream of events which is pushed to you, telling you when things are done and certain tasks are done. And if you are feeling really fancy, you could load up a WebSocket client and connect to our WebSocket server and then retrieve those pushed directly rather than polling for updates.
Yeah, I'm polling on a timer. Basically, I'm managing internally a list of units, which is this read-only shell view, which is a list of units. And what I do is, in any time I run a timer, I check inside this list of units if the stage is registered. So I only poll for the ones that I know that need polling. I'm not polling for all of them. I can have 100 units logged onto the application at once, but I'm only polling for those that are in the non-registered state. So I only want to pick out those that are registered, and then I go through them in a for loop, for each loop. And if the return from the read says that it's okay, I go ahead and move it into the next stage, basically.
Great. Thanks, Ian.
That's how that's moved forward. Let me come back to my other. Okay, so the next one is we found that we have a problem. There's whoever's written Cloud Actions, more Cloud Actions tasks, and some of the cloud software that you can write inside Octave, you've realized that if you have many cloud actions, you will end up repeating parts of those cloud actions, like adding your API credentials or routes or addresses or like the company name or things like that many times over inside each one of these. And these files are normally open, so somebody can come in, read that file and say, okay, I have Ian's password, like I just showed a minute ago, but this is Ian's username and password, so we don't want to have that information out in the open. So how do we store that? And how do we store certain resources, like things that we want to keep? Like if we want to keep a threshold ID or number in there, or something that we want to use across different edge actions and cloud actions, we would just have to repeat that. So if that makes it hard to administer, especially if you need to change one of these values, you have to go in and change it in every one of these cloud actions, these tasks, or whatever you want to do. So let me hope I was presenting here. Okay, so the concept of a vault or a store is good, though Octave does not provide it quite now. Out of the box, it can be implemented. If we think of streams inside of Octave as non-SQL data tables, like if we think of a stream that we create and we add objects to it as a non-SQL database, and that every stream element is a row in that database or an item in that database, we can take advantage of that. And that is exactly what we did well, we do in most of our projects. Let me come back in here. No, let me go to this one, and let me come back up here. So if I go back in here and I come into streams, I have a stream in here that's called Secret Vault. This is a stream that I created by adding a stream, giving it a name, and creating it. I cancel it. This stream has two messages in it. One message is where I keep a number of resources inside the element. I'm using the same structure that Octave used, but inside the element, I have a JSON object that represents my data, where I can keep URLs, I can keep folders inside my resources names, stream IDs, company names. I can have any number of objects in here stored. Also, I have another one, which is my secrets, which is basically, I have my elements in here, and I have my AWS logins, I have my secret keys, I can have certificates in here, I can have all kinds of things inside of these two elements, and I can add more elements on these. The thing that I do is I need to come into, manage groups, and I create a group that's called Secret Vault, which has 3 users, and I say that this Secret Vault user group is the only one that can come in and see these, no, let me go here, this Secret Vault. So this Secret Vault is open to this group, but it's not open to any other group. So the users that see this group are only the ones that are authorized in here. So if I go over to users and I look at the current users of this company, there's only 1 user, 2 users, 3 users that can access this stream, which is where the secrets are. So how do I render this? I have basically, let me go actions. I basically have a demo action, Secret Vault demo action up here. This is a cloud action. So I have a boilerplate piece of code, which is this one. Well, actually, it's 2 boilerplate pieces of code. One is this one, and one is this one. That basically do is they go and pick up those stream IDs, and they go and run these, read these stream IDs and get the information. This example here only has one line of code, which is going to say console log, read me this AWS header. This AWS header is not defined, is not visible anywhere. It's got a secret. So if I go and do simulator, oh, come on. Let me just minimize this a bit so I can move it around. I've got a little issue with something that pops up here in front of my thing. So if I come up here and say simulator and just select anything from here, this set, okay, and I run this, you'll see that I have on my console log, I have here exactly the information that I was expecting to see, which is my, again, come on, be friendly. I have that information, which is the secret codes, and they're not inside here. So if I would go now and into my streams and change something, let me just change, what one was I looking at? I'm not sure which one I was looking at, AWS header. Okay, so if I just change this to just a number of X's in there. Oh no, I need to edit that. Let me just edit. So if I to edit this into a number of X's and this into a number of X's and save it, and I were to go back to my cloud action and run that cloud action again. Let me go back into the simulator. Let me go back and take another one of these, set, and I were to run this again, you would see that I'm getting that completely corrected, and that would run across every place I need to use it. So if I have, and we have deployments in customers that have 50 cloud actions or 20 cloud actions, I don't know the numbers. If you need to replicate that over 20 cloud actions, that is a lot of work. This just automates it and takes advantage of a storage that is here and that you can use as a table. So if we look at this stream secret vaults as a table, it's got 2 records in it, and those records are actually non-SQL records because they are JSON objects. And that would be it for me. I don't know if we have any questions.
Well, that's very nice. Thank you. Any question for Ian? Guys, I don't see any question so far. No? All right, I was actually very happy to see how you use Octave groups to protect and this way of using Octave is really clever, I think, and that's a great feature. Definitely a great feature. A secret vault. Okay, we have a question. Oh, okay, thank you. Someone saying, Andrew saying that was extremely useful. Thank you. All right. All right, so thanks, Ian. Thank you very much. It's really appreciated to have you with us today, to share with us a few codes you have implemented for your real day-to-day job in the IoT and deployments with Octave and so on. That's really awesome. I hope we'll have other people sharing with us what they are doing. I think it's extremely valuable. It's a way as well to give us idea of what's feasible, how, I mean, all the different ways to use Octave. I think that's very very useful. I have other comments saying thank you, very useful, great guys. Thank you for your comments. So yeah, so that's great. Thank you. So any questions for Matt or Jan on any other topic? I mean, maybe that's the time for you guys, if you have, like Jan used to do usually, to ask questions on Octave as a general topic. So now that's the time.
And we'll continue doing.
For sure. Thank you very much, Jan. Any question? Any question, guys? I don't see any more questions. Nope. No one. Okay, so I think that's it's time to wrap up everything now. As usual, if you have any questions at any time, you can go to the forum and ask your question there. I guess Jan is on the forum as well. You can contact him whenever you like, or Matt, myself, or anyone from Octave team. Next time will be December 9th, so very soon we'll have other subjects. We'll have another UI subject, I think, for you guys at that time. As always, register for the live session if you are not already. You can follow us on Twitter. You can subscribe to our CRLS YouTube channel so that you are not missing anything and any Octave live session. I think that's it for today. Matt, thank you very much.
Thank you.
Thank you, guys. Thank you, Jan. Hopefully we'll see you again one day with more features and more things to share with us and the community. And thank you, all of you attending these sessions. We see you next time, December 9th. Take care. Bye-bye.
Bye-bye.
Bye-bye.